Very. What is that?
Powers.
They're over there. Yeah.
Everything good out there?
Yeah, everything's good. How are you doing, Emil?
Good, good.
Good. We'll have to talk. Yeah, just a novel.
William
Gibson. Yeah. Okay. Good evening, everyone. Happy Thursday. How are we doing? Everyone have a good day so far? Tired? Okay. So here's what I'm thinking. Yes. Can we dim the lights? Somebody, please. Yes. Good job, Melvin. Okay, so we are going to have a slide presentation entitled Get Visualized. Get Visualized. Questions? I don't know why I'm stopping for questions in the beginning, but it's telling me to stop for questions. So who has questions? Somebody ask me a question. Okay, guys, and if you could all just pay attention for the presentation, we'll have other times to look at everything. Okay, yeah, laptops down, everyone. Let's do laptops down. In fact, I'd like to, before we get started. Sorry. Can we all just get up and stretch? Are you guys cool with that? Get up and stretch real quick. Okay, so everyone, we're going to stretch out. Take a deep breath in, arms above the head, stretch to the left, stretch to the right. Take everything out, shake off everything from your day, everything you went through today, everything that's not in front of you, web development. Let it go. It's not serving you. Okay, awesome job, everyone. And if anyone else does any like yoga or meditation or anything like that, where's Pedro? I know Pedro's a dance teacher, so if you want to lead us in something, or any of you guys that just said it to me, I do. If any of you guys ever want to lead us in like a quick stretch or a quick breathing exercise or anything like that before we start. Okay, Matt, you're all going no. Pedro, you want to do it. You know you want to. Oh, yeah, that might not be great for this class. But if you ever die first thing in the morning, your incidental meditation Yeah, I didn't have much range of motion either. Okay, so let us begin. Everyone, your attention, please. Your attention, please. Okay, so we're going to talk today about collaborative coding with Git. Who set up a Git repo yet for your team projects? Anyone? Okay, this team did, this team, 2 teams did. Okay, so we're going to talk about this. We talked about in our very first class, we said Git is what? It's a system that allows us to collaborate together effectively, right? Without stepping on each other's toes, which is important. So, this diagram here is basically a flow chart that shows how a large group of developers can work together on a single project collaboratively without stepping on each other's toes. Basically, you'll have change requests. So when the developer wants to change something and add the code they added, they do what is called a pull request. The pull request says, hey, I made this code, you fill out a description, say what it is. Then you'll have one or more other developers, depending on how you have it configured, that can approve it. So you can set this up on GitHub if you want to, if that's something you want for your project. It's not required, but you guys should find some kind of way to work collaboratively on Git. Another thing that I'm going to do before I go further into this presentation, I would like all of you to download SourceTree. If you haven't already, I've gotten with some of you individually and told you about this tool, but for any of you who haven't, yeah, and go ahead, get on your laptops and go download SourceTree. Madison, did you ever go to work? SourceTree? No? Okay, I'll try to help you out with that. So everyone downloads SourceTree. SourceTree gives you a graphical user interface for Git, which is going to come in handy when you have multiple branches that you'll be merging and stuff, and you want to see how everyone's code works together. It's going to be very helpful for you to see it visually.
How do you spell it?
Source, S-O-U-R-C-E, tree, T-R-E-E.
Should we integrate with Bitbucket?
You can't, no, don't for now because you're using GitHub. SourceTree is made by the same company that makes Bitbucket, Atlassian. They also make Jira, which is a common project management tool you guys will be using. That's okay. What happened?
I guess my delivery this one on the line.
Wait, what line?
The Bitbucket.
Oh. Okay. I don't know. Maybe one of those you had to be there things. Okay. So basically this diagram shows us that we might have 1, 2, 3, 4, or 5 files that are on GitHub. And then down here we have a picture of our computer. So basically all this is showing us is how we can use Git to work together collaboratively. We'll keep things locally on our computer. I talked to you guys already about how Git is decentralized. So you have a local repository that lives on your computer, and then you push it up to other decentralized repositories like the one on GitHub. But you can have your Git repository actually linked with many decentralized repositories, which we'll see when we learn about Heroku and how that looks. So this is just it. If you guys download SourceTree, that's going to be pretty much your best friend for learning to use Git together. The workflow you guys should typically use is when you start a new feature or fix a bug, make a new branch for it from the master, and then when you're done, merge it back into the master. If you decide to use pull requests, you can fill out a pull request first and then get approved to merge it back into the master. If that's the way you guys want to do it, you can also have multiple branches for your releases. Like typically what people will do is in addition to having the master branch where everything is stable, they'll also have a stable like beta branch or a testing branch. So you could have just the testing branch. So you'll merge things into the testing branch, then test it with everything else. Then if everything looks good, then you merge that into the master branch. I know that's a lot, that's kind of a mouthful, but do you guys sort of understand what I'm talking about at least? And you'll get the hang of it if you just get on and are committed to working together and you guys will figure this stuff out. It's really not that hard. So you can add things to Git as we've seen. We can commit things to Git. You guys should all be familiar with this by now, right? If you use SourceTree, it will give you a nice graphical user interface for this to make your lives easier. So you can see here's what we're doing when we're adding a new file. You can make branches. You guys all know how branches work, right? Okay, so a branch is basically you're branching off. So you have your code base. Think about like a website that you built that has like an assets folder, then there's a CSS folder, there's a style sheet, it has an images folder, there's some images. There's some JavaScript to the whole project structure. When you make a branch, it's going to take that whole project structure, make another sort of copy of it, and then you can work on things on that copy so it won't affect the original. Like say I say to you, hey, Melvin, go fix this button in the CSS, it's green, it's supposed to be red. So if we were using branches, what you would do is you would go and you would create a new branch, and you would call it like red should be green bug or something descriptive that tells basically what it is. If you're using a bug tracking or issue tracking system like Jira, you can put the Jira ticket or issue tracking ticket as the branch name. So you'll make your own branch. So that way you're nicely sandboxed. So all of the changes that you're making won't affect me as I am continuing to make changes to the code. It won't affect everyone else on the team if they're continuing to make changes to the code. Then when you decide you're done with this one task, making the button from red to green, then you will merge your changes back into the main code, into the master. If you decide to use pull requests, you will fill out a pull request. When you think you're done and you're ready to merge your changes back in, you'll fill out the pull request. Another developer on your team will take a look at what you did and then approve it. If it gets approved, then you can merge it back in.
But
to your
the master will be edited with the new revisions.
After you merge it back in, yeah. So he'll make
So you
revisions.
have to be 100% sure that the code is functional.
Right, so you have to test, yeah, you have to test it and make sure it's functional. So that's why we have pull requests, so we can have many sets of eyes on it, so one person doesn't just say, oh, I'm done, and push it in. You have 2 or more people that have to sign off on it. Does that make sense to you guys? Any questions on this, how branches work? Yeah, Nelson?
How do we set that up? You're gonna talk about that?
I don't know if it's in the slideshow, but I can absolutely go over that with you guys. So let's just get through this slideshow here. This basically just shows which is active branch to be the alternative branch.
You can put a person like a student manager in that, and that person is the one that allows the pull request to be admitted or something like that.
Wait, say that again? Yeah, you can choose who gets certain permissions. You can choose who can approve pull requests. You can choose who has permissions to merge to certain branches. You can configure all of that stuff. I haven't really configured these things myself. So, okay, so this is all there is. So let's take a look at SourceTree. I'm gonna see if I can download SourceTree onto this computer. Hopefully it will work. Download for Windows. Okay. Have you guys all installed SourceTree onto your computers by now? It's not doing it? What's wrong? Okay. TAs, could you walk around and while we're doing this, actually see if you can help people? Awesome, thank you. Go to my Atlassian, use an existing. So part of the problem might be that you need to have an existing Google account or Atlassian account. So that might be part of your problem.
Once you open up the app.
Okay. So guys, if you guys want to focus up here, I connected first. I had to have an Atlassian account. Then I'm going to link it to my GitHub account. What I can do now, I can actually skip this setup for now. Load SSH key. No, you don't need that because we're not using SSH keys.
Do we clone our group's repository?
Sorry, I'm trying. Do we clone a repository? Yeah, I'm gonna get to. Yeah, I'm gonna get to that part in just a sec. Sorry. Download an embedded version of Git for standalone use. Browse to. Okay, so it's asking me. I don't have Git installed. In order to use SourceTree, you have to have Git installed. So I'm installing Git now. Yeah.
That SourceTree does the same thing that the GitHub GUI that
it does some of those same things. They're not exactly the same because GitHub is a centralized repository that's web-based. This is a client for your computer. So GitHub actually has another app that's an app that actually installs on your computer that does basically the same thing that SourceTree does, but not as well. If you installed the GitHub app for Mac, that's what you're saying. Yeah, uninstall it and then install SourceTree.
Different things that does the same thing.
Yeah, so uninstall. Yeah, so uninstall GitHub app for Mac and then install SourceTree because SourceTree will be a lot better for you. Sorry? Okay. So let's say, welcome Mario. We're just talking about Git and how we're going to use Git to collaborate together. That's fine. So here, for example, I'm just going to show you guys, say I want to clone this repository I made today for the RPS multiplayer game made with Require.js. I can just copy the URL. You guys are all familiar with this, how we just copy the clone URL, right? When we want to clone a repository, you guys have all seen this before by now, I hope. So I just paste this in here. Then I say I want to clone a new repository. The destination path, it automatically makes a new folder in documents, and then it's going to say the local folder is the root. And then I just click clone. It quit. It must be because Git is not, yeah. So this isn't working on my computer, so I won't be able to show you guys. Who hasn't gotten it installed locally yet?
It's been installed, it's being very buggy.
To your Google account.
Yeah, just connect it
Some
to
of them
your
are
Google
being very
account.
buggy with like logging in. They can't even log in to their Google account or anything.
Huh. That's
What
weird.
about Git Kraken? Have you tried using
I
Git
forgot
Kraken?
about that.
No, I'd rather we all use this, so it'd be sort of standardized. Yeah. Yeah,
It's
sign
like
up.
an empty
Did
page.
you, Madison, did you drag it to your applications folder when you installed it, or is it still in downloads? Oh, okay, you don't need to drag it.
Oh, it shows a drop-down menu?
No, I got all my GitHub into it, so it has all my repositories.
Did you select the destination? Did you select the
I haven't done so, I just, I don't know.
Oh, so you have to select it because, okay, so. That's a meeting, you were in
The thing also that when they said that we couldn't start it, when we went and we start the client. It's been used.
Yeah, so try making it new.
I got it.
Okay, you got it to work? Okay. Okay, so I guess we're getting it to work. While you guys are doing that, maybe we can multitask a little bit and I'll just go over some of the features on Git. And I don't know, I'm not actually the most knowledgeable about this, but basically what you can do, since some of you were asking me about how do we collaborate on Git, how do we configure Git for pull requests and all of that. So if you want to add collaborators, the first thing that you guys are going to do is find out your team members' GitHub usernames. So just to show you, what's somebody's GitHub username, so I can add you, just to show you. Mappy Pina, one word. Mappy Pina. Okay. So now I've added Mappy. So now Mappy is allowed to collaborate with me on my game. Now, so I've at least invited her. She has to accept the invite. Now I can see I have branches. We can choose to protect certain branches. So I can choose to protect master, let's say. Branch protection. So now this is where I can configure the pull request. So if anybody wants to add something to master, I'm going to require that we review a pull request from them. And then it's going to ask me, do I want to dismiss stale pull request approval when new commits are pushed? So I'm going to check this. This means that, say somebody adds a pull request and then they go back and they add something else to it, that pull request is just going to go away. Sometimes this gets annoying because sometimes you'll create a pull request and there'll be just one thing wrong with it. And then you don't want to go back and create it again. You just change the one thing. So you don't always need this. Require review from code owners. Require an approved review in pull requests, including files with a designated code owner. So I could say I could say, Mappy, you're the owner of all of the CSS for this project. So if anybody wants to merge CSS into master, then it has to go through you. You have to be the approver. Yeah.
What is the co-owner? The person that creates that file?
Well, not the person who creates it, the person who's in charge of it. Like, say I'm running an organization, right? And I say, Mappy, you're going to be in charge of all of the CSS for the organization. You're the owner of all of the CSS. That means that she's basically responsible for keeping track of it. So if anybody else works on the CSS, she's going to need to look at it to make sure that it's okay. Make sense?
Yes.
Okay. So, and then you just have a few other options here for how you want to configure your pull request and configure the protection for this protected branch that we've configured master. Require status checks, so you can do a status check on it. When enabled, commits must first be pushed to another branch, then pushed directly to master after status checks have passed. So this is just another thing that you can do to protect your code. You guys probably won't need this for this project, but it's really for much larger projects. But you can play around with this stuff just to see how it works. Some commits have to have verified electronic signatures to make sure that it's really you. that's doing it. You guys won't need that. And then you're going to enforce configured restrictions for administrators too. So typically if somebody has an administrator role, they won't need to have pull requests reviewed before they submit code, but we can choose to enforce this rule even for the people that have the administrator role. Any questions on this, guys? We just covered a lot.
Yeah, you did.
So is this making sense to all of you? Sorry, a fork and a branch?
Yeah.
Okay, that's a good question. We've covered this before. Basically, a fork is when you want to take a project and make it into something totally new, something totally your own.
Okay.
Branch is when you want to make a change to the project and then merge it back in to make it a better version of the same project. Any other questions, guys? Are you guys all pretty clear? Are you guys going to all be able to go to GitHub, go to the settings, branches, and figure this stuff out? The collaborators, the branches, add your team as collaborators here. Then go to the branches. You're going to make master branch protected, and then you're going to do what I just showed you guys.
Be a collaborator to do a pull request.
So this is how we branch protection. Do you have to be a collaborator to do a pull request? It depends on the configuration settings. So typically though, no. Typically you can go to pretty much any repository on GitHub and submit a pull request. And then if they decide to approve it, it will get merged in, otherwise it won't. Any questions, guys? You guys seem nervous about this. I never knew how to do this. I'm just learning to do this now too, as I'm explaining to all of you. If that makes you feel any better about it. I don't know if it does. It makes you more nervous or something.
We ask when we have questions.
Yeah, I Google or I read I actually like read the words and then figure out what they mean. What?
Okay.
Yeah, okay. Well, just pretend I've been doing it for years and years. And I have been doing, I mean, some of this stuff for years and years. And the reason that I've been doing it for years and years, and the reason that I'm good at it is because I read things, I absorb them, I figure them out, and that's it. So, any other questions on Git? Who has SourceTree installed yet?
I haven't installed it.
Oh, you're not logged in. Okay, well, if you haven't done it by now, you can do it later. We're going to stop that for now, and we're going to talk a little bit about architecture, and then you guys are going to get to work on your projects in groups. So everyone, are you good? Okay, can we all do laptops down for a second? Okay, so who watched my video last night? Any of you, some of you? So this is all stuff that we hadn't talked about before. I know that might have caught some of you by surprise that you're expecting to be a nice, easy, like explanation step by step of how to do homework, and instead I started talking about architecture and all these things. The reason for that is if I had tried to explain step by step nicely how to do the homework without explaining the architecture part, we would just be totally lost in the weeds, and it would be even more confusing. If you separate everything as I showed you guys into nice, clean modules where you have lots of small functions that do similar things encapsulated in a module. For instance, writing things to Firebase, every function that you have that writes something to Firebase should be about maybe 3 lines of code, because all it's doing is it's setting something in Firebase, right? And then you have all of those functions labeled, so you can see clearly what they are without even having comments. And then you think about how your app's architecture is going to work. Like for the Firebase RPS example, what I basically was thinking was you're going to have 2 points of entry where information can enter into this system. It's either going to come from Firebase through a push notification or from the UI through a DOM email, right? So things can get into the system 2 different types of ways. Then we're going to take the information that's passed in. We're going to perform a set of transformations on it. And then we're going to give it back to the opposite end. So if something comes in from the database, we're going to take it, we're going to perform a set of transformations on it, and then we're going to give it to the UI. If something comes to us from the UI, we're going to take it, we're going to perform a set of transformations on it, and then we're going to give it to the database. So you can think of your whole application architecture in terms of the way that the information flows through. So you can think about it, it's almost, you used the example of a car, Melvin, so I'll go with that. It's almost like figuring out how to do the wiring on a car. where you have different little modules of electronics with housings on them, and then you're figuring out how to plug them all in together so that they work together. So it's a lot like that. So what I would like all of you to do is think about the architecture for your applications. What modules would you want to create for the different things? Like say, for example, you're using OMDB, you would probably want to create an OMDB module that would have functions for, say, getting movies by title, getting movies by actor, etc. If you're using Firebase, you should make a database module that has all of the things that you'll want to write to Firebase in it. Like say you're updating a username, you'll make a function in your database module that says update username or send update username. I want to show you guys. Yeah.
How, using your architectural analogy, how is that different from pseudocode?
It is very similar to pseudocoding. Pseudocode is more like you're saying what you want to do in plain English. This is, you are still using plain English, but you're using kind of a hybrid of plain English and JavaScript syntax. So I'm giving all of my functions plain English names. So they're following the syntax for JavaScript, but I'm doing it in such a way that it also makes sense in plain English. So let me show you this. Yeah, so yeah, it's a lot like pseudocode 2.0. So here's what I did here. I have my app.js. I'll just bump this up here a bit. So I have my app.js. This is where everything sort of starts. This is just the require config for require.js. So all this does is it pulls in our external library dependencies. We have 3 of them. We have jQuery, we have Bootstrap, and we have Firebase. So it pulls all of them in this way through this config function, and this is just a cleaner way to do it than putting the script tags in your HTML. You don't have to do it this way. Yeah, Martha?
I did notice basically 3.1, it doesn't like, and the one that I got is like 4 point something.
You can use the link, so you just replace the link. As long as this link works with the .js on the end of it, you can just replace it. So then that's all this require does. It pulls in jQuery for us, it pulls in bootstrap.js for us, and it pulls in Firebase for us. So then the other 7 things we have here are just the event listeners. So we talked about how data can flow into our application from events pushed to us from the database, or it can flow in from events pushed to us from the UI. So these first 3 listen for events that come from the UI. What information will be coming from the UI? Well, if somebody submits the username form, we're going to do something with that. We're going to take it, we're going to perform a series of transformations on it, and then we're going to send it to the database. If somebody submits the chat form, we're going to do the same thing. We're going to take that information that was sent to us, we're going to perform a series of transformations on it, then we're going to send it to the database. When the player clicks a rock, paper, scissors, they're passing in that information into our system. Did they click rock, paper, or scissors? So we're going to take that information, we're going to perform a series of transformations on it, figure out who won the game, all of that. Then we're going to send that information to the database. The database is then going to call an event here that we'll be listening for, and then we're going to update the UI. So then the things that we're listening for from the database, the push requests, the first thing is when a chat gets sent, when a new chat gets added to the database, we're listening for that. It'll push that data into our system. We perform our series of transformations on it, show it in the UI. Same thing when a new player gets added. That information gets pushed into our system. We perform a series of transformations on it, show it in the UI. Same thing for these other 2. When a turn reference gets changed in the database, when we update the database field for turn, it does the same thing. It listens for it. When that happens, it takes that information, it performs transformations on it, then it updates the UI with it. Same thing when a new player joins the game. So from looking at it this way, we can sort of see what's really happening with our application in terms of the way information flows through it, which gets really important when you get into more and more complicated applications. So you can see that, yeah. It's not React, sorry, it's Require. I kept making that same mistake too. Yeah, we're gonna learn React later. You don't technically need it. I would suggest that all of you use it. I know it's like, oh no, I have to learn a new thing. But yeah, but it's not really that. I gave you guys all this code so you can use it as like boilerplate and then just keep adding these new modules. You guys got instructions to do the object-oriented kinds of ways of doing things from the rock, paper, scissors game. Remember, it gave you that suggestion in the homework. So this is that same type of thing. It's organizing your code into new modules because you're going to have a lot of code. It's too much code to just throw all together in one file. So having it in different files even is helpful because you can switch whenever I want to edit something in the database. Say, then I'll just go to my db.js file and I know the database code that talks to Firebase is right here. If I want to update something in the UI, then I just go to my UI.js because I know that all of my UI code that talks to the DOM with jQuery is here. So it really makes everything easier. I know it's a little bit of a speed bump kind of to get into using this, a little bit of a learning curve, but I really would suggest that you guys do it. And I think it will be worth it to you, but you don't have to. So, I mean, it's up to you. Use your judgment on this. I will be willing to help all of you on this. And if you don't do it this way, I'm going to kind of say, well, why didn't we do it my way? You know? Yeah.
Okay, so this process, we keep coding, we're getting to know this style, this process.
Yes. So Node actually has this require functionality built into it. So this library, Node.js, was kind of inspired, I think, by what React has natively, where you can use require. That's a native part of Node.
We are going to learn React?
We are going to learn React and we're going to learn Node. React is a product from Facebook that kind of adds even more structure into your front-end web applications to stop it from being a jumbled mess, like I was showing you guys last night. React also does some other things to make the UI updating faster by using something called the shadow DOM. And I can explain, just to give you guys a little bit of appetite whetting, I'll explain what that is now. It's basically, you know how in jQuery sometimes we'll create DOM nodes and then we won't attach them to the document object model right away. We'll first do things to them, like we'll add an attribute, we'll add some text to it. Remember how I said it's just floating out in space? So what the architects at Facebook did was they figured out how to make a whole copy of the DOM that's just sort of floating out in space. So you take it, you make all the changes you want to what they call the shadow DOM, and then it writes it to the DOM. So by making this whole copy of the document object model that isn't attached to anything, it makes it a lot faster. That's called the shadow DOM. So that's one of the things that React does for you. The other important thing that React does is it gives you structure for your application like this. Yeah.
So .js file, right?
This is require or React? Well, we're learning require now. Yeah, this is require.
I think he's saying,
Yeah, well, I was talking about React just now.
right, so is there a React.js file?
Yeah, there is, but we'll learn React later because the React is even harder to learn.
Okay, so I was just gonna say,
Okay.
so it's not the same as using like a reset for CSS?
No, it's not. I'll get to you in a second, Dan, but I just want to make sure that we understand this. So React is something that's more in depth that we'll learn later. We're not covering React now. We're covering require.js now, right? Everyone clear on that part? Yeah. So you can use, I'm trying to think. So your question was about React, right? Not require? And it was, I just want to understand. Sorry.
Well, I thought that it was what you were saying that you would use React for your JavaScript.
It is similar. I see what you're saying. Yeah, it's kind of similar to that because it like resets everything. In a way, it's kind of similar, kind of. I'll think about it. Maybe I can come up with like an analogy to explain it more. Okay. Yeah, let me think about it. I'll see if I can come up with a better way to explain it. What was your question, Dan?
I was just gonna say,
Vue.js. No, I don't have experience with it specifically. I can look into it though. It's probably would be pretty good for this from what I do know about it, which is not much. So any questions on doing things this way and whether you choose to use require.js or not? What you can do is I want you guys to think about the architecture of your application. Where will information be coming into the application? How will it flow through the application? What are the transformations you will be applying to your information as it flows through the application? What is the end state of the information? So you can think of pretty much everything in all of the software development you'll be doing as a series of transformations of information as it flows through your application. And this is actually the clearest way to think about stuff, even though it's a little bit confusing at first. When you learn to visualize these things, you guys are going to get totally sick of me hearing me say high-level visualization, blah, blah. over and over again. But the reason, there really is a good reason why I keep saying this stuff, it's because this is really what works. This is what's going to make you guys good software developers, learning how to visualize how the information flows through your software.
So in other words, would that be similar to being in the shoes of the user? Sort of, no?
No, not really. Because think about it here. So there's a user, he's standing out here, he's pushing buttons. So you have a soda machine. And inside the soda machine is this big, crazy tangle of wires that goes and connects everything, and connects the buttons to the part of the soda machine that drops the soda. And there's all these tangled wires everywhere. That as the end user of the soda machine, you just push the button and you get a soda, right? We're talking about all the way all of this craziness back here happens with all of the tangled wires and stuff. You're trying to kind of untangle them and couple them together, put some nice neat little twist ties around them, and all of that. You know what I mean?
Yes.
So that all of the wiring is clean and easy to follow. If somebody comes in behind us to fix our soda machine, they'll have an easy time figuring out where all the wires go and stuff. Yeah.
How are global variables avoided using the require?
Okay, that's a very good question. How are global variables avoided using require? So the way that this part works is that everything in require, if I go back to my app.js, since this is where sort of everything starts, you can see that everything inside of require happens inside of this callback function. This callback function has its own scope. So this is like a container, so nothing in here touches the global scope. This is sort of like padding that protects everything from touching the global scope. Then when we need things from another file, like we need things from our handlers file, we need things from the database class or module, and we need things from the UI module. So we'll just pass in these three dependencies here. As an array, that's the first argument that it takes. The second argument is the callback function when all three of these things load and they're ready to go. So yeah, so it manages dependencies without clogging up the global namespace with a bunch of stuff. The only global namespace that we're using in this case is require. Even jQuery, you don't have to have a conflict. jQuery is no longer going in the root namespace. In case some other script we had would be using a $, there would be no conflict with jQuery, because the way that require does it is it just pulls in jQuery, and then when we use, I'll get to you in a second. When we use jQuery in our UI.js, we are just declaring it here as a dependency. So we're saying jQuery here in our array that we're passing in as the first argument, and the function that we pass in is the second argument. In the first argument of that function that we're passing in as the second argument, we pass in $. And so that's how $sign gets used. But nothing gets put in the root namespace. Okay, thanks. Good question, Elliot. Sorry, who else had a question? Somebody else was raising their hand. Oh, okay. Okay, so can you guys, having heard all of this, I know that you still have a lot of questions and I don't expect all of you to get it right away. But having heard all of this, can you start thinking about how you would architect your application? How you would start splitting the code off into different areas. So you're going to have some code that's going to update things in your UI. Then you're going to have other bits of code that are going to go and talk to the various APIs you have. Then you're going to have other bits of code that are going to go and talk to Firebase. Then you're going to have other bits of code that are just going to be like utilities. Like here, I made this form utility because I noticed there were several things that we were doing with forms over and over again. So I made a module just for forms to handle all of the things I had to do with forms. If I want to get a value out of a form, if I want to validate a form, if I want to reset a form. Okay, so what questions do we have? Because some of you are looking lost. Don't worry about the implementation. Don't worry about the in-the-weeds details. High level. Can you visualize it? How the information is going to flow through your application? Can you visualize how you'll compartmentalize the logic into different sections?
High level, yes.
Yeah. So this is sort of what we're practicing here. And I want you guys to practice this in the right way, which may be a little bit more uncomfortable for you at first. It may be a little bit more of a stretch to visualize how all this stuff is going to work together. It's easy to say, okay, I'm going to open up my laptop and I'm going to figure out where to put the semicolon. And then I'm done. And I'll just do that like a million times. And then I'll be done. But if you just do that, then you just wind up with a big mess because you're not thinking about the high level. Okay, so is this making sense to you guys? Are you guys sort of getting where I'm going with this? I know that it's a lot and you have been doing software development for a very short time. So this is sort of a big, tall order. Yeah, 8 weeks, yeah.
So in plain English, what you have is the same JavaScript for a web page, but in different files.
Yeah, I have the same JavaScript that we had on the original web page, but it's in different files. And the reason I broke it up into different files is because they all do different things. So I want the things all compartmentalized nicely because there's so much code. If we just mush it all together, it's going to be really confusing to look at. So all of the stuff that does things with the forms, that goes in one file. All of the things that do stuff with the database, that goes in one file. All of the things that do things with the UI, that goes in one file. Okay, any questions on this? Any way I can help you guys to
The individual JavaScript files don't typically end up sharing any variable per se, right? Unless it's
sometimes they do. So let me talk about that. That's a good question. That is a good question. So this is what we do. We have public and private variables. Hopefully, who knows public and private variables from studying Java? Really? Only? Okay, you do too. So basically, sometimes you'll need things accessible from outside of your functions, and sometimes you won't. Like, for instance, this getValue function is only accessible from inside my form.js. The rest of these are accessible from outside my form.js. If I want to call validate, I just return getValue, which is a local variable. So in computer programming, we have a concept of what is called public and private. So private means that this getValue function can only be called from inside of my form.js. The rest of these that start with this dot binds this to the global scope. So then I can call these from another file. Like here, I'm going to show you guys. So you can see here how I'm calling form.validate. That's calling the validate method from my form module. Does that make sense? And I can do this because I'm telling it up here that I want to require util.form. And then here I'm going to tell it that I'm going to call it form. And then anytime I want to do one of my functions that works on forms, I can just call it by doing form.reset, form.whatever, form.validate.
Form dot and then the name of the function inside.
And then the name of the function inside. Then it's form because I declared it right here in the third argument of the callback function. If I called it something else, then it would be that thing. And if you guys don't get all this stuff right away, don't worry about it. This is just to get you thinking about how to structure your applications.
so the first portion in the define DB UI util / form, those are referencing the specific JavaScript files.
Yeah,
And then
exactly.
in function, that's how we're labeling anything that we're trying to call from those files.
Right, that's how we're labeling it. So I'm saying, go get me the JavaScript file called db.js. It infers that there's going to be a .js after this. Or go get me UI.js, or go get me form.js inside the util folder. Right? And then we're going to call these. Within here, I want to call them these things, db, UI, and form. I can call them anything that I want, as long as I state it here.
And just like you did 3 there, you can do 5.
You can do 5, you can do as many as you want.
Where do you put the Firebase?
Okay, good question. So Firebase, I took out the script tag to Firebase the way you guys had been doing it, and I configured it here in the app.js, like I showed you. So we're pulling in Firebase. I'm telling it, here's the URL to get Firebase,
Yeah,
right? So, okay, so I'm going to show you that part too. I just want to make sure we cover all of it so no one gets confused. So I have this require.js.config where I tell it all of the vendor scripts that I'm using, all of the outside scripts that I'm using. I'm using Bootstrap, I'm using jQuery, and I'm using Firebase. Then in my db.js, I'm saying define Firebase. So I'm doing the same thing with the dependencies here. I'm just saying I want to get Firebase, and I'm going to call it Firebase when I use it. Make sense?
Yes.
Okay. Okay, so I think this is all we have to do. Yeah, we took more time than we were supposed to, in fact, talking about all of this. So I would like you guys to think about roles for your group, though, as well. You don't have to do it right now, but by the end of the night, I would like one person who is the project manager. I think this is a good way to do this. This is not in the instructions, but would you guys like to do it this way? Where you have one person who's going to be the project manager who will write out all of the tasks and stuff. Or you can split it if two of you want to split that responsibility, you can do that too. But I'd like one or two people to be like the project manager where they write out all of the tasks and assign them to people. Then I would like one person or possibly two people if you want to split the role to be like the designer on the group to figure out how the visual presentation will look. Then I want one person to be the architect to figure out how all of these modules and stuff will fit together and how the whole flow of the application is going to work together from a high. You guys good with that?
Yeah.
Okay. Okay, so we'll go ahead and get started. Do you guys have your sketches by now? You also do have your sketches? Yeah, okay, so go ahead and send those to me when you have them. Send me everything that you have as you have it. Send me links to your repos when you set your repos up. Okay?
Personal message on Slack?
Yeah, message me on Slack.
Okay,
Professor?
Yeah.
Can you the roles project manager?
Yeah, they're in the, you don't have this locked up.
Y para eso